Welcome back to Math 168. I am Professor Robert Needing, and we'll be covering Section 3.4, Bootstrap Confidence Intervals Using Percentiles. This will be the end of Chapter 3, leading into Section P.1. Yeah, let me get rid of this stuff here. Don't need that. So, Section 3.4. Basic overlay, confidence intervals based on Bootstrap percentiles, the different levels of confidence, impact of sample size and the level of confidence on that interval width, and the cautions for Bootstrap intervals. When we talk about a percentile method, it says if the Bootstrap distribution is approximately symmetric, meaning we don't have spikiness within inside of it, we don't have skewness, then we construct a confidence interval by finding the percentiles in the Bootstrap distribution. So the proportion of Bootstrap statistics between the percentiles match the desired confidence level. Often, maybe you've taken a test, and in that test you were ranked in some kind of percentile. Maybe you were in the 90th percentile or the 70th percentile or whatever have you. A percentile merely refers to the percentile values below a given certain value, and in a picture kind of form. What I mean by that is that if we had a symmetrical shaped curve, and statistics says that if we give a test enough times that it will look bell-shaped and symmetric. And let's say I score in the 90th percentile. What that means is that 90% of the data is to the left of me. 10% of the data is to the right of me. I am in the 90th percentile, meaning I outscored this 90%. And that's the way you always want to think about it. But the opposing is true, that there's 10% who outscored you. Likely, if I made a similar looking curve, and let's just say I scored in the 40th percentile, meaning 40% are to the left of me and 60% are to the right of me. And when you think about percentiles, that's what you want to think about. So if there were 100 people here, then 40 of them would be to the left and 60 of them would be to the right. Same here. If this were n equal 100, then 90 people, or 90 dots, would be sitting here, right? Because we count by dots in this, and 10 dots would be over here, approximately. Back to our slide. So when we look at that distribution of those values, we have a lower bound and we have an upper bound. And you're bound by a percentile on a two-sided interval distribution by an equality on both sides. It will be symmetric on both sides. So if the left boundary is 10%, then the upper boundary is 10%, but 10% from the top. The observed statistic, or the p-value we talk about, is in the center. For a percentile confidence interval, we keep the middle percentile of the Bootstrap statistic. For a 99, we'll keep the 99 middle, leaving 1/2 on each tail. And for a 99 percentile, it says that would be the 0.5th percentile to the 99.5th percentile. Okay, well, that's a little bit of a word there to talk about something that's pretty easy. If I have a 99% curve, 99% of the data is sitting in here. Well, remember that leaves 1% for the outside, and it means 1% divided by 2 leaves 1/2%. And so when it talks about the percentile, that means this cutoff point here, right here, has to be the 1/2 percentile. And remember, we got to include the 99 plus the 1/2. This is the 99.5 or 99.5th percentile, meaning that only 1/2% of the data dots or data population is here, and only 1/2% of the population is over here. Simple concept. Wiley question number 5. It says to create a confidence interval from a bootstrap distribution using percentiles, we keep the middle values and chop off a certain percentile from each tail. And that's what we were doing here. I was chopping off a 0.5% and a 0.5%. I was chopping off 40 people and 60 people. I was chopping off 90 people and 10 people. I was chopping off somewhere to make something applicable to what I needed. Okay, so let's continue with that question. Indicate what percent. And when you're reading these questions, make sure you know whether it's a percent or an actual given value. So it wants the percent of values that must be chopped off from each tail for the confidence. All right, if it's a 95%, then we have 5% left over. But remember, 5% left over is 2.5% from each side. We would leave 2.5% on each tail. And that's the clue there, each tail, left side, right side. If we had a 98%, well, 98% says that we have 2% left over. 2% divided by 2 is going to be 1%. And again, it's from each tail. Go down to the next question. It says the same basic thing here, but now what it says is that chop off some number of lowest values and highest values. So now they actually want values, how many of them. Now it's important that we know how many n values there are, and there's 1,000 samples in here. We're going to need that value. So on 95%, if we use up 95%, that means there's 2.5% left in each tail. And I'm going to write that down. So 95 subtracted from 100. And actually do what I'm doing in my head here so you can see what it equals. So when I do that, that equals 5. Then that 5 has to be divided by 2, because each side we have to have 2.5% in order to cover it. Okay, well, what we really need to calculate then is 2.5% of 1,000 data characters. And 2.5% of 1,000 data characters, or 1,000 Bootstrap samples, is 25. We'll do the same thing for the top one up here. And I'm going to take and I'm going to highlight this. And I'm going to put it back down here now. I'm going to control it in. Now, in this one, it's 98%. So now we're subtracting 98% instead of 95%. That's going to be 2 divided by 2, which is going to be 1%. 1% of 1,000, is 10. So it'd be 10 values from each one. How you do when you're given a value number. In a random sample of 1,000 people, 382 agreed, 573 agreed. Wow, that's a little messed up. They both say agreed. 40 cannot decide. Use stack key to find 99% CI for the proportion of population to agree. Okay, so obviously there's a typo in this slide, and one of these numbers is supposed to be agree and one is supposed to be disagree. So I'm going to say that the first one is supposed to be disagree. Okay, so let's say that we are going to utilize this number right here. Okay, let's say that's our agree. Let's say the first one is 382 disagree. Use stack key to find a 99% CI for this. Okay, so first of all, we got to go out and we got to find stack key. I'm going to go to stack key, Google it up. And I'm going to go into a single proportion for a bootstrap. The first thing I'm going to do is I'm going to edit my data, and I'm going to put in the 578 out of the 1,000 samples that were taken. That was the data that was given right here, 578 out of 1,000. So I put 578 out of 1,000. First thing I'm going to do is I'm going to generate 1,000 samples. And I'm going to run a two-tail. When I change a two-tail, I'm going to change the middle value to 99%, 0.99, because I'm using technology to do all of this. And I can see down here at the bottom are my confidence interval levels, 0.534, 0.617. So 534 and 617 will be my numbers. 534 and 617. 0.534 and 0.617 is my 99% confidence interval level for 578 agree. Now, if your question is different with a different number, then put in something different than 578 out of 1,000. It says if we stimulate more Bootstrap samples, the width of the CI will, and these are important to you, and I would suggest you highlight them, underline them, do what you have to do here, will likely remain the same. Just because you make more Bootstrap samples, the CI will stay approximately the same. If I go back here, see my CI 534 and 617, let me generate some more. And hold on, I got to change it back to 99.99. And you can see I'm at 537, 617. My CI will stay likely the same because I've generated more samples. Not exactly. It always changes slightly, but more than likely it stays pretty close to the same just because. And notice it says likely will remain. Level of confidence. As the level of confidence increases. So now, as I change this from, for instance, 0.80, let's be exaggerated here. If I make it an 80%, look how narrow the black is, but how thick the red got. If I change this to a 99, watch just the opposite happen. The black will become very large or wider, and the red will become narrower. So the question here says, as the level of confidence increases, the width of the CI will increase. Absolutely, I just made that happen. Sample size. If you increase the sample size, the statistic calculated is a better estimate. Another important statement for you. As you increase the sample size, the width of the CI will decrease. Why will it decrease? Because it's a better estimate and it doesn't need to be as wide to capture the true population parameter. Question number 18 asks these very same questions. It says, general confidence intervals using paired structure of the data will be narrower than confidence interval ignoring structure. How else could we change the width of a confidence interval? More specifically, for each of the following changes, would the width of the confidence interval, and these are our choices right here, will it increase? Will it decrease? Will it remain the same? If I increase the sample size, okay, well, remember, increasing the sample size, let me get my text box here. If I increase the sample size, it will cause it to decrease the CI. Stimulate more, likely remain the same. We just got done talking about that will be about or approximately the same. If I go from a 95 to a 99 percentile, what will happen? Well, it will get larger. It will increase itself. I did that when I went from 80 to 99. I was a little more dramatic on mine. A Bootstrap CI. You have two options when we're talking about a confidence interval level from a Bootstrap. Option number one, we did back in the previous chapter, where we take the statistic and we calculate plus or minus 2 times the standard error. Now, a notation here, you can only use this method for a 95% confidence. If it's not a 95% confidence, then you can't do what we're trying to do here. I'm trying to get rid of that color right there and it won't go away. I highlighted everything I didn't want, which is crazy, isn't it? Okay, well, here, I'll do this. I'll do the anti one here. I'm going to do this right there. Watch that. Boom. Option two. So let's say it's 97% or 98 or 99%. You have to generate a P confidence interval and use the range in the middle as the P percentile for the Bootstrap. That's where we use this and then change the value in the center. We can also do that with a calculator, and we'll learn how to do that pretty soon. Either the standard error method or the percentile method will give a 95, so you can use it for either one. But if you're outside of a 95, you have to use the percentile method. These are some Bootstrap cautions. First of all, these methods are for creating confidence interval only work if it is smooth and symmetric. If it's not smooth and symmetric, you can't do it. Always plot your data. You got to see what it looks like. You just can't take it for word that you think it's going to be okay. If it is spiky, like the one on the right-hand side right here. Look at that one right there that's way high up there. Or if it has gaps in it, this one has some gaps here, so you lower and then it spikes back up again. You need to go beyond this course in order to create stuff. Normalizing data, which is a technique outside of what we do here. When using Bootstrap sampling, you get a slightly different confidence interval each time. We saw that. When I calculated and I ran the number up, it made it a little bit different. For the purpose of this class, 1,000 samples is fine. To me, the word fine means not good enough. In reality, you probably want 10,000. That's usually my number right there. If the directions don't tell me how many, I'm going to run 10,000 all the time, because 10,000 will give me a much better estimate of the true CI. Hey, we're at the summary already. That's awesome, isn't it? On a 95% confidence interval can be created using the standard error or the percentiles. Either one of these will calculate a good CI. For any other desired level, you have to use the percentile method. Okay, so that's really the one thing I want you to take away from this end, is that if it's not a 95, you have to go to the percentile method. A confidence interval from a Bootstrap percentile can be created for any parameter. That's important. So I can do it for any of the parameters. So I can do it for a p-value. I can do it for a mu value. I can do it for a rho value. Difference of values. As long as distribution is approximately smooth and symmetric. Smooth and symmetric. Excellent. Okay. That ends chapter 3.4. We'll be moving into section P.1, and we will talk about probability. Thank you. See you then.